Today we're going to have a look at our last really new topic for the year, which is a little bit about human population growth. We're going to apply some of the concepts that we've learned about population ecology in general, and we're going to explore a few more tools that we use to look at human population, and a few other bits and pieces that that may arise around a population as unique as the human population that has a lot fewer of the restrictions that other populations have. So trends in carrying capacity are a good way to sum up what we're about to look at. I know this came up when we were talking about K strategists in general, and I'm sure that everybody sort of made that connection that we are pretty strong K strategists. Again, keeping in mind that this is the K and the R strategists are something that you use usually comparatively, and when we talk about humans compared to most other species, we're aware that we follow that pattern where we have few offspring. We do start reproducing later in life. We tend to provide a huge amount of care, more than any other critter really, to our offspring. And for us, that has been a very successful strategy. We know that our population has continued to rise, and in fact, to the point where recently, really, the rises are quite startling. This little bar graph here shows population increase in the world since 1950. So we can see that we've doubled at least once in that time frame, and are well on our way to heading toward doubling a second time. And this is only from 2000. So we haven't looked at the last, or this particular graph doesn't look at the last 14 years. So given the rate that this is increasing at, we can be pretty certain that we have gone over another doubling, say, since 1950s. That's a huge amount of growth for a population. All right, this term demography you've probably heard of before. It's a pretty common word, especially when we're looking at studies of human populations for any particular reason. So it could be a study done by an advertising company, could be a study done by medical researchers, could be a study of humans done by some anthropologists, all kinds of different things. And we use it sort of governmentally. They use it to design infrastructure in communities and so on. So all kinds of uses for this. So it's a study of the statistics of population of humans, and includes all kinds of things that we've been talking about already, including density distribution, birth and death rates. This is quite a complex graphic. Over on the left-hand side, we're seeing, they're calling them stages. So we're looking at pre-industrial, then the second peachy color, the large one here, stage 2 transitional between pre-industrial and industrial, which is stage 3, and then stage 4 post-industrial. So they've kind of broken down all of the countries in the world and followed some stats about those particular groups. And looking at birth and death rates, you can see as we move toward the post-industrial that our birth rates drop dramatically, and also our death rates drop dramatically. So over here at the end of stage 4, where you see that the pink and the red cross, at that point, what we would find at that stage of post-industrial growth, that those countries, the population would be going down. So to be considered post-industrial, your death rate and your birth rate have to be pretty close to the same. And then as you sort of work through that, generally what happens is the birth rate goes down even further and your population is declining. Where we're seeing way over here in the pre-industrial that the red and the pink are kind of up and down, and they're relatively high compared to a post-industrial. The other one there is population growth rate, and we can see as the birth rates, even though birth rates are going down, if death rates also go down, we're seeing that populations can increase. So if the populations reach their potential, the growth rate can increase quite rapidly until you get to the post-industrial, where the growth rate tends to go back down again. So there's a lot of information on this graph about a lot of different kinds of communities in the world, and there's some examples at the top of what might classify or fall under those stage 1, stage 2, stage 3, and stage 4 categories. So through history, we can see a very classic J-shaped curve here. Not surprising. We understand that human population is growing exponentially, and we can see for the first little while, for the first 2 million years or so, we were ticking along without too much in the way of increase in population, because like other critters, we're limited by some of the basic things such as food, the predator-prey relationships, disease, and so on. After about 8,000 BC, when we started to plant things and stop moving around so much, you can see the population is on a steady increase. We would maybe call this our lag phase, and continually increasing until the Black Death or the Black Plague, where the population dipped a little bit. And after that, after things improved a little bit, our population took off and into what we have nowadays. The videos that are here, I will also put onto D2L, so you can watch those. So you can look there for those postings as well. And if I can access the St. Mary website with this particular PowerPoint, I'll post the PowerPoint without audio on that website. So the agricultural revolution really brought human populations, or really sort of moved them toward that increase, that lag phase from sort of no growth to a slow growth. And until this time, the Black Plague hit in 1347 to 1350. It was a pandemic in the sense that it took out a huge portion of the largest population in the world at that time, which was in that sort of European area, and definitely halted the worldwide population. And we think of it as being an old thing, but this second picture here, the one of the man in the hospital bed at the top, this was not too long ago. I pulled this off a news article in the States, and there was a man who was diagnosed with something. Took them ages. They couldn't figure out what it was that he had, and it turns out that he had the Black Plague. So these ancient illnesses that we think that we've eliminated can sometimes rear their ugly heads again. You can see that there's quite a lot of damage done by the time they figured out what was wrong with him and got him on the right drugs. All right, so just after the plague, our population grew very rapidly. So we started to hit the log phase, or the exponential growth phase of our population graph. And that's due to lots of reasons. We started to move forward. We had so many people, I guess, if you want to look at it that way. We had some time to do some dividing of labor. Everybody wasn't just trying to survive. So we had some time to look at things like improving our agricultural methods. We improved our medicine, so people were surviving better. We could combat some of the diseases that were out there. And we got better at storing our food over winter, keeping the critters out of the food, which led to a much more conducive lifestyle for people. And of course, we entered the age of the Industrial Revolution. And you can see the picture here showing some child labor going on here, and that was very much the norm at the time. So as we started to industrialize with the invention of the steam engine, things changed rapidly in the world. And again, with this YouTube video, I'll post it on D2L, so you can watch it. When you get to this point, you can stop this video and watch the other one if you like. All right, so here's another way of looking at the world's the population that changes from 1950. This one is predictive and goes ahead to 2050. And what's interesting about this is if you look at the purple region, those are those post-industrial and industrial countries where the population doesn't really change a whole lot, but the less developed regions, those pre-industrial regions, the growth rate or the population there can increase rapidly with the use of modern medicine and so on. So our populations in places like China and, well, not so much China anymore, but say India, those populations are rising incredibly quickly and will continue to do so as their living conditions improve. So overall, the birth rate in the world has remained about the same. 30 births per 1,000 persons per year is the rate that I've given here, but the death rate has been dropping from about 20 deaths per 1,000 people to about 12, and that's going to make a difference to your overall population, keeping in mind that the birth rate is not changing. If they're both going down, then we would have a stable population growth, but that's not the case. So our annual growth rate is in fact around 1.1% per year. So we're still going up in terms of our population on Earth. However, we're not going up as fast as we were. So maybe our curve is starting to level out a little bit. In the 1960s, our growth rate was around 2%. So obviously we've come down from that. And it's the numbers here. And again, I won't ask you to remember the numbers, but the idea that our growth rate is being reduced, not our population. Our population's still growing, but our growth rate is reduced. And we're a little bit lower than, certainly about half of what we were previously through the 1960s or through the baby boom years. So because the growth rate is declining, we're thinking that at some point we may actually be able to balance the population of humans on the Earth. And the predictions are that by 2050, our growth rate will be less than 0.5%, still growing, but maybe able to be brought under control. All of this is assuming that we don't have some sort of pandemic that reduces the world's population. So this would be a prediction. We can see there was a big peak in the 1960s, and then on into sort of predictive area where our growth rate is going down. Population's still going up. So this is not a population graph, it's a growth rate graph. And that rate is at least going down. We'd like to see it, if we can have any hope of being able to maintain a decent lifestyle for the humans that are on the planet. We'd like to see it at 0, ideally from a biological or from an ecological standpoint. All right, so a little bit more about this, talking sort of relating this to doubling time, and as we mentioned, going into the end of the 21st century, we should have a much slower growth rate. But again, there are so many people on the planet that it's predicted here by 2042 we'll have at least 9 billion people on the planet, and really we don't know if our planet's able to sustain that kind of population. And this is the UN prediction of when the population will stable just after 2100 at just above 10 billion people. So a whole lot more people going to occupy the planet at that point in time. Not my problem, but perhaps some of you guys will be around to see that. All right, so here's one prediction. Please note there's an awful lot out there, an awful lot of data out there that that would have estimates that are a little bit different from what we're seeing here. We're just using this as a bit of a guideline. So if we look at our doubling time when the population was a little lighter, our doubling time was sitting at about 200 years. In the boom time, so with the boomers taken into account, we were all the way down to 45 years. And now, or a little bit into the future, we're thinking that the doubling sorry about that, cut myself off. We think the doubling time will slow down a little bit, which would be good. When you have 6 billion or 7 billion people on the planet, a short doubling time is most likely going to lead to some pretty severe issues with limiting factors and carrying capacity of the Earth. In terms of the populations that are on the increase now, a lot of the, again, the same graphic we saw before, a lot of the developed countries, or what we call developed countries, like North America and a lot of our European countries, are in fact either close to zero in terms of growth rate, or are in fact have a negative growth rate, so the population is going down. Countries where the birth rate is very high and the conditions are improving, so people are living a lot longer, that's where we're seeing a lot of the growth in population worldwide. So certain countries in Asia, certain countries in Central and South America, we're seeing a lot of changes in those areas and a lot of growth in those populations. One way that we can look at what's happening with a population overall, and this is one form of graphic that we see a lot in business and we see a lot in government, so in terms of census information, is a population pyramid. And a population pyramid can tell us a lot. So this sort of from a simplistic sense, is going to or can be used to tell us a lot about the potential growth for a particular population. So if you look at the one at the bottom here, this was the age pyramid for the population of Canada from 1901 to 2001. So that's over 100 years. So what happens in the graph, or what we see in the graph along the center in this one, sometimes it's the left or right vertical line, so it can be on either side. So basically along the y-axis, we're going to see an indicator of how old the people at that level are all at that time. So how many people are 100 or how many people are 70 during that time on average. And down at the bottom we see 0. So right down at the bottom we see how many people are being born. And from Canada, other than this big boom year here, all these boomers who are now, when this one was done in 2001, the boomers were sort of between 35 and 65, we can see that our population rate is right down. So we're definitely, the bars at the bottom are much narrower, which tell us that our population base is shrinking, and that our population going forward is not going to be increasing the way it did when the boomers were born. In these graphs, we also usually, although not always, usually you'll find males on one side and females on the other side. And usually the ages are in 5-year intervals, although we can see on this particular age pyramid that the intervals are in 10-year intervals. So as I mentioned, the shape is important in a predictive way, and this gives you an overview of the different kinds of populations that you might encounter. So if you look at the Kenyan population pyramid on the left-hand side, we can see females and males equal, more or less, and we can see that the base down in the 0 to 4, so the first 5 years, we can see that those individual, or first 4 years, those individuals are much greater in number than, in fact, the people in maybe reproductive age that are actually having the children. So this gives us a huge growth potential. If all of those children that are born in that bottom section, the 0 to 4, if all of those children survive, this curve will stop being a sort of bottom-heavy curve, and it will, and those people, as they grow up, would have lots and lots of kids themselves. So this population pyramid is going to get much less pyramid-y in shape and get a lot wider, and the population potential is huge. Where if you look at a slow growth population like the one in the States, we can see that although the bottom one here is a little bit bigger, over the sort of 1970 to 1985, very stable, maybe up a little bit. Maybe we would see with the next demographic, so maybe from 94 to 98, we would maybe see that the growth is going down a little bit. So it's staying pretty stable. The United States still has a slight increase in their population in terms of these population pyramids. But this would be what we would call slow growth, approaching zero growth, possibly over more recent data. And if we look on the right, we can see the population pyramid for Germany. And we can see for Germany that bottom is definitely narrowing out. So the potential for the future population is becoming less. So their growth rate is probably negative, and the population will probably not increase in the foreseeable future. All right, here is a population pyramid from Kenya, different sort of look to it, but same idea. And again, we can see at the bottom, there's a huge growth potential there. Imagine what that would look like if all of these individuals survived. The population would change drastically up through into old age. Obviously, we're going to peter off at old age, but we would see a much wider pyramid and a huge increase in population. As I mentioned, it's showing here that we're bottom heavy, and if we look at it a little more closely, we'll see that half of all Kenyans are under 20 years of age. So what this tells us is that the life is pretty tough, and a lot of people end up dying just after their reproductive years begin. Which means that the Kenyan doubling time could be very short. If all those people survived, the population would double very rapidly. And again, here's another look at the USA. The rectangular shape indicates a stable population. We can see a little bulge again where the boomers were, and they've sort of gone up and down a little bit in their growth rate over the time since the boom, so since the 1960s. And still a little bit of growth going on there at the bottom, but not a lot. So fairly stable, close to zero in terms of their growth rate. In this case, we see only 14% of Americans are under the age of 20, compared to that Kenyan one where it was half the population, or 50%. So again, not a huge potential for growth here. We don't have to, they're not going to be able to double at the same alarming rate that Kenya could if all of their citizens survived. So much longer doubling time. All right, we can also use population pyramids to look at subsets of data. So this particular one that I pulled out here is from the United States. It was crafted, I think it's in 2000. And what we're seeing here is foreign-born Chinese people in the United States. And we're seeing the males on the blue side and the females on the sort of aqua green side. See a lot more females. That might have something to do with adoption rates out of China, where for a while it was a fairly common thing to do, and most of the children adopted were female, and that's for a whole set of reasons from the Chinese standpoint. We can still see that there's a lot more sort of boomers there, and we can see that sorry about that. And anyway, in terms of this subset population, we can see that we've got, again, another boom on the girls' side down at the bottom, again, perhaps to do with adoption from China to the United States. So growth potential on the female side, but on the male side, we're seeing it's negative growth there. And again, it could mean lots of different things, and it gives us some information maybe that might be of interest to particular groups for various reasons. So it doesn't have to be a complete population, i.e. the population of the United States or the population of Germany or whatever it is. We could also choose to use these pyramids to investigate other populations within populations. All right, so let's see whether you understood what we were talking about in terms of population pyramids. So I'd like you to take a few minutes to have a look at these population pyramids and decide what kind of growth you are seeing. So you can pause your video now if you don't want to know what the answers are. Up in the top here, the India population, 2011, the population at that point, you could see that the population is continuing to grow, although it looks like it might be leveling off a little bit. So that would be a growth population for sure. If we look on the top right, we can see the Canadian population, and that population is going down, negative growth. Germany, we've already seen one representation of that. I think it only went up to about 2000. Now here in 2009, we can see that they're continuing to go down, so negative. Now, if you compare Germany to Canada, Germany is much more definitely negative, where Canada looks a little bit more like stable or closer to zero than Germany is, but still Canada appears to be going down. And if you look at the Ontario population, which is the bottom right, we can see that the population of Ontario took a big dive after the baby boom years, and appears to maybe be now slow zero, maybe slightly negative growth in Ontario. So hopefully that's what you guys came up with. And that's the end of our video on human populations and a little bit about how we look at those populations. Have a look at the attached videos, and we'll discuss this in class.